Welcome to the next tutorial on electricity. In this tutorial, we are going to discuss about the factors which affect the resistance of an electrical conductor. We know that the first factor is length. As length increases, resistance increases. Second factor is area of cross section. If area increases, resistance decreases. The third factor we discussed is the material of the conductor. For different material, the resistance is different. And the fourth factor is temperature. And this temperature is little bit interesting. And there are two very specific classes. One is pure metal, another is alloys. For pure metals, the resistance reduces with reduction in temperature. That means if the temperature is reduced, the resistance also reduces. In fact, it is a bit interesting. If the temperature is reduced to a great extent, like minus 200 degrees Celsius, it has been found the conductor will not have any resistance at all. It becomes like a superconductor. Whereas for alloys, the resistance almost remain unchanged with change in temperature. For example, take a glowing lamp at a very high temperature and a lamp which is not glowing, which is at rest. That means the temperature is low, but still the resistance of both of them will be almost same. So for pure metals, the resistivity, and we have already discussed what resistivity is, increases with increasing temperature, whereas for alloys like nichrome, manganese, constantan, then tungsten, the resistivity remains almost unchanged even with rise in temperature. Even when temperature is increased, the resistance remains almost unchanged. Now let us take let us talk about something little bit more interesting. Okay, now we know that formula R equal to resistance equal to rho into length upon area. Take the case of an electrical lamp. You have seen the filament. If you watch very carefully, you will see that the filament is coiled, is highly coiled. Means there will be lots of rounds. And if you take a broken lamp and if you pull the filament, you will see that the length is really big. For example, in a typical 60 watt electrical lamp, 60 watt electrical lamp, the total length of the coil is 6.5 feet. That means even taller than a standard size human being. 6.5 feet means generally a human being will be 5.5 feet. So the length of a electrical filament is 6.5 feet. Whereas the area of cross section is only 1 upon 100th of an inch. So cross section is very thin, 1 upon 100 inch. Whereas the length will be 6.5 feet. That means much taller than a standard size human being. So length is increased to increase the resistance, and area of cross section is reduced to increase the resistance, so that the electricity will face lot of resistance and it will produce lots of heat and light. So that is how this principle is used to build a electrical lamp. Now let us talk about the a little bit more about resistivity, that is rho. Now R equal to rho into L upon A, therefore rho equal to R into A upon L. Now in this equation, if A is equal to 1, that means area of cross section is 1 square unit. So in SI unit it will be 1 square meter. if the length of the resistance is 1 unit, okay, then rho equal to R into 1 upon 1, that is equal to R. That means for a conductor having 1 unit of cross section, 1 square meter cross section of area and 1 meter of length, the resistance of that conductor is called resistivity. So resistivity rho is the resistance of a conductor having area of cross section as 1 meter in SI unit and length as 1 meter. So resistance of a conductor of 1 meter length and 1 meter square cross section is called resistivity of that conductor. What is the unit of resistivity or unit of rho? Now unit of R is ohm and A is meter square, unit of A is meter square and unit of L is meter, so it is ohm meter. So this is the unit of resistivity, ohm meter.